If you painted your roof white, would it actually help to keep your home cooler in the summer? A Yale article claims that if cities replace dark roofs with white ones, it can lower heat wave temperatures by more than 2 degrees Celsius. That's a pretty bold claim, so I want to see if it actually holds up. Let's find out. To test this, I'm painting two pieces of aluminum, one black and one white. Then I'll heat them under the same lamp and measure their temperature over time using a thermocouple. It's a simple setup, but it reveals something huge about how color affects heat and how small design choices can make a big difference in temperature change. Okay, so let me explain a bit of the physics. Well, sunlight isn't just the bright visible stuff we see. It also includes things like infrared, which carries a lot of heat energy. When sunlight hits a surface, that energy can either be reflected away or absorbed and turned into heat. Black surfaces tend to absorb most of that light across visible and infrared wavelengths, turning it into thermal energy. White surfaces tend to reflect most of it, staying much cooler. That's why dark clothing feels so much hotter in the sun. And yeah, that's also why my hair gets roasting compared to someone who's blonde. Color literally changes how much energy something keeps or releases. This idea is exactly what scientists call a cool roof. According to the US Department of Energy, a typical dark roof on a sunny day can hit 65 degrees Celsius, but a reflective white roof can stay 25 to 30 degrees cooler. Some cities, like Los Angeles, are already testing reflective coatings on roads and roofs to fight the urban heat island effect. That's when city surfaces trap heat and make the entire neighborhood hotter. So the science sounds pretty solid, but let's see if that happens on a smaller scale. Alright, here's my setup. I've got two identical pieces of metal. They're the same material, same size, and same thickness, because those are my control variables. The independent variable is the color. One is painted black, the other painted white. And here's my light bulb in between them, so each gets the same amount of light energy. And on each plate, I'm going to attach a thermocouple. It's basically a super sensitive temperature sensor. So that way I can see exactly how fast each plate heats up second by second. Okay, I've switched lights on and now we wait. All right, it's been a few minutes and you can already see what's happening. The black plate's temperature is shooting up way faster than the white one. So it's been about 10 minutes and it looks like both of these are leveling off. But the black plate is still several degrees hotter. Now I'm curious what's happening to the air around them because that's what really matters for something like a roof. So I'm going to take the thermocouple off and just hover it right behind each plate. So when I measured the air temperature behind each plate, the air near the black plate was noticeably warmer. So the same pattern shows up not just on the surface, but in the air around it too. But of course, airflow and convection can mess with these numbers a little bit, so this isn't a strict measurement, but a trend is there. So we can conclude that color, or reflectivity, changes how much solar energy a surface absorbs and how much it sends back into the environment. So what does this mean in real life? If more cities use reflective materials, it could reduce cooling costs, lower strain on the power grid, and make dense urban areas more livable during heat waves. The US Department of Energy estimates that cool roofs can reduce building energy use by up to 15%. And the article that I mentioned earlier, that potential 2-degree drop in heat waves could actually save lives. But it's not all perfect. In colder climates, reflective roofs might actually increase heating costs in the winter. And some high reflectivity materials can cause glare or even heat nearby buildings by bouncing sunlight in the wrong direction. So the same white roof that helps in Los Angeles might not make sense in Oslo. But then there's also newer tech like cool pigments that reflect infrared without looking bright white, so cities can stay cooler without blinding everyone. So yes, painting your roof white does make a measurable difference. But I think the bigger lesson here is that sustainability isn't just one big solution, it's lots of small choices done smartly. Because sometimes tackling climate change starts with something as simple as choosing the right color.